So in order to solve equilibrium problems and to get the concentrations of species at equilibrium, we have to use an idea from algebra 2, pre-calc, college algebra, whichever course you want to call it. And we have to use an idea called the quadratic formula. So if you remember way back when, that if you have something in the form, you have an equation in the form of this: ax squared plus bx plus c, and this is equal to 0. Okay, where a, b, and c are numerical coefficients, and a cannot be 0. All right. So if we're going to solve, if we want to solve for x in this problem, we have to combine like terms, and the way that we do that, the way that we solve for x using a quadratic formula like this, is to say the following: that x would be equal to negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And so if you have a quadratic formula like this, or a quadratic equation, in order to solve for x over here is a solution of that formula, of that equation, as long as you know what the coefficients are. All right, so the plus or minus sign right here means that you're going to have two different answers. Okay, and sometimes we call these, sometimes these two different answers, we call these roots. Okay, so let's try this out just to see how this feels. And I'm just going to do a simple, well, not simple. I'm gonna use like a no chemistry involved. Let's just look at how this works, using math. Okay, so what this would look like. Let's say you got this formula: 5.1 x squared minus 1.7 x, and this is equal to 3.2. All right. How do I solve for x? Well, the first thing we want to do is get this equation into the form ax squared plus bx plus c is equal to 0. Once I get into that kind of a form, then I know what a, b, and c are. I can use the quadratic formula and solve for x. So the first thing I need to do is subtract both sides from subtract 3.2 from both sides. So that way I move the 3.2 over to the left. So rewriting that, I would get 5.1x squared minus 1.7x minus 3.2 equals 0. So I have nothing left on the right-hand side. So now I'm in the form ax squared plus bx plus c is equal to 0. So a, in this case, is going to be 5.1. B would be a negative 1.7. And then c would be a negative 3.2. So those are my values. Okay. Now, going back to my quadratic formula, x is going to be equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And so what I need to do is start popping my values in. So in this case, x would be equal to negative 1.7, okay, plus or minus the square root of negative 1.7 squared minus 4 times 5.1, which is our a, times c, which is negative 3.2, okay, divided by 2 times 5.1. Okay, so we need to do a little bit of cleanup here. So I'm also going to need my calculator. That's why I'm pausing. All right, so starting from left to right, we've got the negative 1.7 times negative, so we got to make that a positive. So x would become you'd have a positive 1.7 plus or minus. Now we've got that square root. We got to deal with everything that's in that square root. Okay, so if we take negative 1.7 squared, we should have 2.89 minus, let's see, 4 times 5.1 times negative 3.2, that should give us a negative 65.28. Okay, and then divide that by 2 times 5.1, that gives me 10.2. All right, so now we're getting a little bit, we're getting cleaned up a little. So let's keep going. All right, so now let's deal with inside that radical, the 2.89 minus a negative 65.28. So let me rewrite what I got. Okay, so 2.89 minus a negative means we're adding. So 2.89 plus 65.28 gives us 68.17. So that's what's inside the radical divided by 10.2. So the last thing to do before we start writing, last thing to do is to actually take that square root of 68.17. Okay, and that gives us, that square root will be 8.2565. So 8.256, let's make that 257. Okay. All right, so now, remember we have this plus or minus sign, so we're going to have two different answers. Let's start writing two expressions. So one expression is going to be 1.7 plus what was inside the radical. So this was 8.257 divided by 10.2. And the other expression is going to be 1.7 minus 8.257 divided by 10.2. All right, so that being said, let's evaluate these two. 1.7 plus 8.257 divided by 10.2. So that's going to give us 0.976 is our answer. And we got to write this with the right amount of sig figs. So we had 2 sig figs going into this, so we need to have 2 sig figs. So this would be about 0.98. Okay. For the one on the right, the expression on the right, we have 1.7 minus 8.257 divided by 10.2. That would give us a negative 0.6428. That would be 28. We need to report this with 2 sig figs, so that would be a negative 0.64. Okay, so those would be the two solutions that would make x equal 0. So popping this all in, here was the original equation. So what I'm saying is that x, to make this all true, x would have to be equal to 0.98, or x would have to be equal to 0.64. And that would get x to 0 or very, 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 very close to 0. And so that's how the quadratic formula works. So what we're going to have to do is use the quadratic formula to apply this to an equilibrium problem. So in the next video, that's what we actually do. We actually take this and try to figure out how do we use this in an equilibrium problem.